Okay, so this is a question I saw somewhere. Yeah. So, anyways, it's from JEE Mains 2022. It's an exam. It's like a qualifier exam for JEE Advanced 2022. And the purpose of this video isn't really just solving this question. I mean, it's a really basic question. If you know anything about functional analysis, it's quite basic. And it's not that tough either. It's just calculative, right? Anyways. So yeah, I'm gonna solve this question first, and then we're gonna point out something that can be removed from the question, right? Because it's pointless. Okay. Anyways, so we've been given that a function that goes from natural numbers to real numbers is such that f of x plus y is equal to 2 times f of x times f of y, and we've been given that f of 1 is equal to 2. So we've been given this expression that for what number alpha is the following expression satisfied, and I'm not going to read that one out. I mean, it's easy enough to see, and maybe you can look at some things and find out, oh well, what's that? Yeah, 512. I can think of something related to that. Anyways, yeah, so we're going to start solving this question. So first we're going to take this functional equation into consideration. F of x plus y is equal to 2 times f of x f of y. And what we're going to do is we're going to do like a classic thing, right? You do this quite often when working with functions. But like I said, you have to first specify what I'm doing before directly doing it. Yeah, pardon me. So we're going to let y equal 1 and x free, right? We can just let x exist as it is. So f of x plus 1 is equal to 2 times f of x. Notice that this is f of y, but we set y equal to 1, and y is a natural number, so it's within the domain. Yeah, domain. I remember calculus. F of y, f of 1, right? We set y equal to 1. So now we know that f of 1 is equal to 2 from the question. So we can just simplify that. F of x plus 1 is equal to 4 times f of x. Yeah, hopefully you can see how we got that. Now we're going to do a trivial substitution, I suppose. And also, like, many of you people may say, this is a direct question, this is just an exponential. But no, we don't do that. We go through the rigor. We don't assume any previous knowledge. Anyways, so f of x plus 1 is equal to 4 times f of x. Now let's set f of x. Let's set x plus 1 is equal to say y. It can be anything, and notice that y is I suppose an integer. No one cares. Anyways, f of y is equal to 4 times f of x minus 1. No, wait, x, but then x is y minus 1. So f of y minus 1. Notice that f of y minus 1. And now this is like a recurrence relation again. I don't know, I've just fallen in love with recurrence relations like lately. I just like them a lot. Anyways, f of y minus 1, right? So now we can use exactly this then. Now we can use exactly this relation, but instead we get 4 times 4 f of y minus 2. So hopefully you know how we got there. If you don't, then you should like study up on recurrence relations. That's how you get there. So anyways, you can keep going and going and going, and what you'll notice is we get 4 times 4 times 4 all the way to f of 1. Yeah, some brackets and stuff. So I think that's the right amount of brackets. Wait, yeah, another bracket. Yes, OCD indeed. Yeah, so we get that stuff, and what you'll notice is we have this 4 y minus 1 amount of times. So we get 4 to the y minus 1 times f of 1 is equal to f of y. Now we know what f of 1 is. F of 1 is equal to 2. F of y hence is equal to 4 to the y minus 1 into 2. Now you can multiply this out a bit, like simplify it a bit. So 4 to the y upon 4 times 2. Now you can cancel some stuff out, and you get 4 to the y upon 2 is equal to f of y. Notice this y is any variable, right? So it doesn't matter what it is. So we just we just let y equal to x because it doesn't matter. So f of x is equal to 4 to the x, pardon, 4 to the x upon 2. Yeah, 4 to the x upon 2, right? So hopefully you're with me so far. So I found out what the function is, and well, first and foremost, one of the biggest discrepancies, okay, although you have like a lot of questions in this paper, so it may be fine to give them one value, but then again I don't find that to be right. So I don't know, maybe like make them compute it, so we get like, so maybe we could do it without this one. Let's try, right? So we let x equals 0 and let x equals y equals 0. Maybe we'll try that, right? So we get f of 0 is equal to, well, no, we can't, because they're defined to be natural numbers. Yes, great. Okay, anyway, so yeah, no, maybe they did need that part of information, that part of the question, I don't know. Anyways, so yeah, this is f of x equals 4 to the x upon 2. Now we can get straight to the question, right? So what we could do is plug in every value of f of x and stuff into that. So what you'll notice is, so we get a pattern, right? Get f of x, well, right now it's alpha, right? So it doesn't matter though, it's a dummy variable at the end of the day. So yeah, f of alpha plus f of alpha plus 1 plus all the way to f of alpha plus 10. Okay, so for the first one we have alpha equals to x, so that's pretty basic, 4 to the alpha upon 2. For the second one we have 4 to the, now alpha plus 1 is equal to x, right? So we plug in alpha plus 1. Notice that that's alpha times 4 upon 2. Now I'm not going to write it like that because I know what I'm doing. Yeah, for once I've started to solve questions before I write them on the board. Anyways, so yeah, we get that, and now you probably see the pattern. So you get this stuff all the way to 4 to the alpha upon 2. Wait, no, yeah, it was alpha plus 1. Yeah, that makes sense. So we get, so this is the second, now this is for, oh wait, we don't get this term actually, yeah, because k is never equal to 0. Yeah, I apologize. I just assumed like everything starts at 0 as a rational person would. Anyway, so you probably noticed a pattern anyways, right? So it's like, well, you get 1 4, but then if you, well, let's do it up to like 2 terms. So the second term would be, well, 4 to the alpha plus 2, but 4 to the alpha upon 2 by using exponent rules. That's 4 squared times that stuff. And now you should see a pattern. If you don't, I'd recommend CAT scan or something, I don't know. Sorry. So anyways, we get that, right? And that's our expression, that's our desired left hand side of our question. Now we can factor out this, we see this is common everywhere, so we can factor it out. 4 to the alpha upon 2 is common everywhere, and what we're left with is this something that people call a geometric progression. If you don't know anything about this, then again, I don't know why you're watching this really. I mean, you should know stuff about it. Anyway, so this is the geometric progression. So it's like an arithmetic progression, but rather than a common difference, it has a common ratio. And here it's quite clear, the first term is 4 and the common ratio is 4. So and the formula for the sum of an AP is like, wait, Sn is equal to, wait, so it's A. Okay, so since the common ratio is greater than 1, yeah, that's therefore the formula would be like r to the n minus 1 upon r minus 1. Yes, I remember. Okay, that's great. Although like both work, you can just factor out a minus sign from both of them and you'd get a 1 minus r to the n upon 1 minus r. It's still the same thing, but the latter is mostly used for r less than 1, right? Okay, anyways, so now what we have is, for this one we have a is equal to 4, so 4, we have r is equal to 4, again 4, and we have a total of 10 terms, 4 to the 10 minus 1 upon, well, 4 minus 1, I'm just gonna write that's 3. So if I don't slur my words again and again, we get the following, right? This is like a note, this is like a side note. So we get the following: 4 to the alpha upon 2 times 4 to the 10 minus 1 upon 3, right? And I hope you've started to notice some similarities between this expression and this expression. Yeah. So okay, so let's convert all the 4s to 2s. Let's see what happens. So okay, the first we're going to add this, so we're going to remove this one, call this 4 to the alpha plus 1. Yeah, and then we're going to make it like a 2 to the, well, let's see, yeah, 2 to the 2 alpha plus 2 upon 2, right? Yes. And then wait, no, maybe we don't have to. Okay. Trust me, dude, I'm a doctor. Yeah, I did this before, but like I just don't remember stuff. I'm trying to not cuss in my videos nowadays. Anyways, 2. So this becomes 2 times 2 to the 2 alpha. Yeah. Okay, that makes more sense. And upon 3, we can just take this out, and then 2 to the 20 minus 1. So yeah, now this should be like pretty much exactly similar, though this is 2 to the 2 alpha plus 1 upon 3 times 2 to the 20 minus 1, and that's supposed to be equal to 512 upon 3 times 2 to the 20 minus 1. Now if you've done, I don't know, if you like past 9th grade and you like math kind of, you should know that 512 the power of 2, you know, because you've probably done the thought experiments and I don't know, played and stuff. So by comparing these two, so you can just, I guess, cancel these because you know that they're strictly greater than 0, and again cancel these because 3 is again strictly greater than 0, I think. If I'm wrong, correct me, of course, if 3 is equal to 0 somehow. So we get the following: we get 2 to the 2 alpha plus 1 is equal to now 512. Notice that that's 2 to the power 9. And at this point, I'm just going to assume that both of these sides are strictly positive. Yeah, they are both strictly positive. Who am I kidding? So I'm going to take log base 2 on both sides. So it's pretty easy to see that 2 alpha plus 1 is equal to 9. Or for an 8th grader, let's not introduce logarithms. Let's just say we're going to compare both sides exponents, right? Yeah, let's let them keep their innocence. So from here it's quite easy to see that alpha is equal to 4, and yeah, that's all. Pretty much out of the question. The question wasn't that difficult. It was just like slightly calculative, and you didn't have to do all this stuff. If you're like a person who wants to give this exam, you're probably made to memorize that functions of this kind are exponential functions and stuff and all that. So yeah, I don't like the memorization part like at all. You know, you should like derive it all, but then again, you don't have enough time, and you want to get into college, so all that shit. Anyways, yeah, that's the answer we get. And yeah, what I wanted to point out was, well, let's see, right? We have this function we've been given that it goes from the natural numbers to the real numbers, which is technically valid because, well, all the outputs of this are real. Yeah, but for all x that are real, natural, this will never be a rational number. Even this is always how do I put this, this is always a natural number. Yeah, not an integer, a natural number. I mean, it is an integer, but you know, we want to reduce it. So yeah, we don't require this real part. This could have just been natural part, and you know, you could have saved them some, I don't know, brain cells or something, I don't know. But yeah, that is just like one small discrepancy that triggered my OCD. So yeah, anyways, this is pretty nice. And if you're looking for the nice part in this video, well, okay, let's see. So 4, right? So wait, so if we take ln of log base 2 of our answer of alpha, sorry, not a number, of alpha, this is log base 2, right? So what we get is, okay, so ln of log base 2 of 4, log base 2 of 4 is 2, So we get ln of 2, that is approximately 0.69, and that is nice. So indeed I have, accomplished everything I needed to in my life. I would like to thank everyone who helped me to get here and all that fancy speech shit. Yeah, pretty nice question though. Yeah, pretty cool. Anyways, yeah, nice.